Hello everyone, today we'll be looking at some quick solutions of All India AATS Test Series JEE Main 2019 Test 4 Code A and B. We'll be looking at the chemistry part. So let's start with the first question. Question number 31. An aqueous solution containing 18.5% by weight of calcium hydroxide has a density equal to 1.2 gram per ml. Find the volume required of 1 molar H2SO4 to neutralize 20 ml of this calcium hydroxide given to us. So let us first try and figure out the concentration or the molarity of this calcium hydroxide given to us. So students, we have been given the density of the solution and we have been given the percentage by weight of the solution. So we know that the molarity can be written as 10 into x into d by m naught, where x is the percentage by weight and d is the density in gram per ml and m naught is the molar mass of the species. So putting the value 10 into 18.5 into the density given to us is 1.2 gram per ml upon the molar mass. So calcium hydroxide has a molar mass of 74, and upon simplification we get the value of molarity equal to 3. Now all that is left in the question is to equate the milliequivalents of calcium hydroxide and H2SO4. So students, MEQ of calcium hydroxide should be equal to MEQ of H2SO4. So now using the data given to us, the molarity of calcium hydroxide is equal to 3, its N factor is equal to 2, and the volume given to us is 20 ml. And if you look at H2SO4, its concentration is 1 molar, its N factor is 2, and the volume we have to find out. So students, on solving this expression, we get the volume equal to 60 ml. So students, the answer which we are looking for in this question is option 2. Let us look at the next question. Question number 32. So it says 14.9 grams of hydrated salt BaCl2.xH2O was heated and the mass of the anhydrous salt remaining was equal to 10.4 grams. So students, we have to find out the value of X. It is given to us that the molar mass of barium is 137 grams. So students, we can apply POAC on barium atoms in this question. So the moles of Ba in hydrated salt should be equal to the moles of Ba in the anhydrous salt. So we can probably firstly try to calculate the molar mass of BaCl2. So MBaCl2 will be equal to 137 plus 71. So it comes out to be equal to 208. So if we talk about the moles of Ba in the hydrated salt, the given mass is 14.9 grams. The molar mass shall be 208, that is for the anhydrous part, plus there are some water of hydration as well. So we have to add that mass as well. So 208 plus 18x, it is equal to the mass of the anhydrous salt remaining. So that is 10.4 upon the molar mass of the anhydrous salt, which is 208. Okay. So if you look at the term on the right hand side, this is the moles of the anhydrous salt and this was the moles of the hydrated salt. So we can try and solve this. So we have 208 upon 208 plus 18x. It is equal to 10.4 upon 14.9. So if we solve this expression for the value of x, we'll have the value of x equal to 5. So students, the given salt is BaCl2.5H2O and the answer which we are looking for in this question is correctly given in option 2. Let us look at the next question. Question 33. So it says hybridization of central atom of cation of solid PCl5, solid PBr5 and solid N2O5 are respectively. So students, if we look at the solid state of these given species, so we have PCl5. It exists as PCl4 plus PCl6 minus. If you talk about PBr5, it also exists in a similar fashion. So we have PBr4 positive and PBr6 negative. Lastly, if you look at N2O5, in the solid state, N2O5 exists as NO2 plus and NO3 minus. So students, the examiner seems to be interested in the hybridization of the cation. So we have PCl4 plus, we have PBr4 plus, and we have NO2 plus. So students, if we look at the cationic part of this given species, so we have PCl4 plus, the hybridization of phosphorus here is sp3. If you look at PBr4 plus, it also has a similar hybridization for phosphorus. It is also sp3 hybridized. And if you look at NO2 plus, so the nitrogen in this species is present in a state of sp. So students, if you look at the options very carefully, we can see that the correct set of hybridizations is given in option 3. So we have to mark option 3 as the correct answer to our question. Let us look at the next question. Question number 34. It is given that SO2Cl2 reacts with water to give a mixture of H2SO4 and HCl. We have to find the volume of 0.2 normal COH whole twice required for the neutralization of 20 ml of 0.2 molar SO2Cl2. So students, if we talk about this species SO2Cl2, when it reacts with H2O, it gives us H2SO4 and HCl as it is mentioned to us in the question. Now if we try and balance this equation, we'll have a factor of 2HCl and we'll have 2H2O reacting with this species. So students, if we look at the solution which is created, so it contains 1 mole of H2SO4 and 2 moles of HCl upon dissolution of 1 mole of SO2Cl2. So if we talk about the N factor of this species, we can try and figure out the number of H plus ions that it furnishes in the solution. So 1 mole of SO2Cl2 will produce 1 mole of H2SO4, which furnishes 2 H plus ions. And if we talk about the HCl which is produced, so 1 mole of SO2Cl2 also produces 2 moles of HCl. So this will also furnish 2 H plus ions in the solution. So if we look at the total number of H plus ions which is furnished by 1 mole of SO2Cl2, we have 4 moles of H plus which are furnished. So we can say that the N factor of this species is equal to 4. Now we can equate the MEQs of the acid and the base. So we have the concentration of SO2Cl2 given to us as 0.2 molar. Its N factor, as we had seen just now, it is equal to 4. And the volume given to us is 20 ml. Now if we talk about calcium hydroxide, the concentration term which is given to us is normality. So we have 0.2 into V. So on solving this, we can see that the value of V is equal to 80 ml. So students, if we look at the options, we can see that the correct option is option 4. Let us look at the next question now. Question number 35. An oleum is a mixture of SO3 and H2SO4. The percentage labeling of oleum gives the composition of the oleum. So it is further mentioned to us that if 1 gram of an oleum sample when diluted with water requires 30 ml of 0.8 molar NaOH for complete neutralization, then the percentage label of oleum sample is. So students, what happens is we add water to the oleum sample and the SO3 which was present in the sample is converted into H2SO4. So let us assume that the mass of H2SO4 which was produced by 1 gram of oleum sample be equal to X. So 1 gram of oleum, it produces X gram of H2SO4. Now if we look at the concept of neutralization, we have the MEQs of base which is equal to 30 into 0.8. And if we talk about the milliequivalents of the acid, so we have H2SO4, its mass is given to us as equal to X, its molar mass is 98. So this represents the moles of H2SO4 and we have to multiply it by the N factor. So N factor is equal to 2 and we are dealing in terms of moles here. We have to convert this number into millimoles. So we'll have to multiply this by 1000 as well. Now if we solve this expression for the value of X, we have X is equal to 1.176 grams. Students, the amount of H2SO4 obtained by 1 gram of oleum sample is equal to 1.176. So by extension, if we have 100 gram oleum, we'll have 100 x gram of H2SO4. So if we solve this number, we'll have 117.6 gram of H2SO4. It means that the percentage labeling of the oleum sample is 117.6%. So students, we have to mark option 2 as the correct answer to our question.